9-1, linear and nonlinear systems of equations. What's a system of equations?
Two equations.
Yeah, just two or more equations. What is a solution to a system?
The answer.
The point that what? Yeah, it's just where the equations intersect. That's all it is. Okay. So we're going to use substitution. We're going to do graphing. We're going to do both linear and nonlinear equations. So we're talking about like maybe a line and a parabola, right? So there could be one solution, no solutions, two solutions, infinitely many solutions, all kinds of stuff going on. Up to this point in the text, most problems have involved either a function of one variable or a single equation and two variables. Many problems in science, business, and engineering involve two or more equations and two or more variables. To solve these, you need a system of equations. Here's an example of a system of equations with two unknowns. A solution to the system is an ordered pair that satisfies both equations in the system. To do this, we're going to solve the system of equations. Substitution. Do y'all remember how I would write the word substitution? Y'all remember me kind of writing it weird?
I still remember exactly how you wrote it.
Side by side, right? We had the S and then BS, right? Side by side. Okay. And I write it that way because when you're doing substitution, if you'll write the equations side by side, it makes moving back and forth from one equation to the other a lot easier. So let's go ahead and do this one because this problem is a little bit more difficult than the example they give us in a moment. So if I'm going to solve this system by substitution, the first thing I'm going to do is write it side by side. So I have 2x plus y equals 5, and I have 3x minus 2y equals 4. They're side by side. Does anyone remember the first step? Yes.
Are we doing substitution? Okay. So what you're gonna do, right? I'm pretty sure I know what you're supposed to do.
Okay, what am I gonna do?
Choose an equation to solve for y.
Or x.
Or x.
And then you said
Y
equal
is
to that.
Okay. Okay, so that's exactly right. Choose one equation. It doesn't matter which one. Get one of the variables by itself. It doesn't matter which one, but be smart about it. Which variable would be the easiest to get by itself?
Y.
Because we have to do that in order to solve the equation. So which variable would be the easiest to get by itself?
Y.
Because it's going to make it easy to solve the equation once you get a variable by itself. Now, which variable is the easiest to get by itself? Because y'all keep asking me why.
The letter Y as in Yankee.
Which y?
The Y on the left.
Okay. Why? Because it's considered singular. A variable is singular if it has a coefficient of 1 or -1. It's always easiest to get by itself. Okay, so I will work with the left equation. Getting y by itself, subtracting 2x from both sides gives me y equals -2x plus 5. Can I do anything else with that equation? No. Now that I know that y and -2x plus 5 are the same thing, I can take that value for y and substitute it into the other equation, hence the term substitution. So I have 3x minus 2. Y, I'm going to put parentheses here. Y is -2x plus 5 equals 4. Now let's work with this equation for a while until I can't anymore. I will distribute the -2. So -2 times 2x is plus 4x. -2 times 5 is -10 equals 4. I will now combine like terms, and I'm also going to go ahead and add 10 to both sides at the same time. Are y'all all right with that?
Yes.
Okay, I have 7x on the left side. Adding 10 to both sides gives me 14 on the right side. Divide both sides by 7. I get x equals 2. Can I do anything else?
No. But
So
now-
I worked with one equation, simplified it as far as I could, got an answer, substituted it in the other equation, worked it as far as I can. Now I'm going to take that answer and back substitute it. That's what they call it. We're just going to back substitute or substitute it back into the original equation. So I know that x is 2. This guy's going to come back over here.
So do we plug it into the y equals one? Or get into 2x plus y equals
The
5?
original 2x.
Now right here.
Oh, that one?
Yes.
Okay.
So we have y equals -2. I claim x is 2 plus 5. And that's just very simple math. -2 times 2 is -4 plus 5 is 1. Which means I think, unless I messed up, I think the solution to this system is the point 2, 1. Now, at this point, the wise thing to do is actually to go and plug it into the original equations, both of them, to see if it's right. Okay, so plugging it into the first one, 2 times 2 is 4, 4 plus 1 is 5, it works. The second equation, 3 times 2 is 6, 6 minus 2 times 1, so 6 minus 2 is 4, 4 equals 4, it checks. So it does check in both. That's substitution, that's all there is to it. Okay, piece of cake, easy stuff. Questions? Okay, there they worked it out there. Next slide.
The second method is the what?
We're going to talk about 4 different ways to solve a system of equations. The first one we just did. The first one was substitution. We're going to talk about graphing to solve. We're going to talk about elimination to solve. And we're going to talk about solving systems using matrices. Here are the steps that we did. Step number 1, we solved one of the equations for one of the variables. Step number 2, we found that answer and substituted it into the other equation. Step number 3, we solved that equation. Step number 4, we back substituted, went back to the original equation. Step number 5, we check our answers. Turn back substitution implies you work backwards. First you solve for one variable, then you substitute value back, yada, yada, yada. Okay. I'm not going to solve this one. Too easy. This is a much easier question. I don't want to mess with any time on solving that. Okay, so the one we just solved and the one we didn't solve, those were both linear, meaning both equations were lines. It is possible to solve systems that are not just lines. We could have 2 parabolas. We could have a line in a parabola. We could have 2 hyperbolas, which y'all have never graphed those before. We could have 2 circles, okay? Let's look at a situation where we have an equation that is a line and an equation that's not a line. We will solve this one using substitution. Equation 1. If I was to graph that, what is it? It's a quadratic. So the graph looks like a parabola. Equation 2, what is it? It's a line. Okay. So to solve this system, we're doing it by substitution. Substitution, I see the SBS, so side by side. I have 3x squared plus 4x minus y equals 7. And the other equation is 2x minus y equals -1. Step number 1, choose one of the equations and get a variable by itself. Y on the line? You don't like the y in the quadratic?
Well, actually,
Okay, either one would be fine. But if I was doing it, I would do exactly what y'all are telling me to do. Do the y with the line. So to get this y by itself, I'm going to add y to both sides. I'm going to add 1 to both sides, correct? Adding y to both sides, adding 1 to both sides. I'm also going to flip it around. I get y equals 2x plus 1. Yes, no?
Well, yes, but that's not how.
Okay. Can I do anything else with that? Okay. So I know that y has the value of 2x plus 1. So I'm going to take that y value and plug it in to the other equation, giving me 3x squared plus 4x minus. I'm substituting that in for y. Do not forget parentheses. So my y value is 2x plus 1 close parentheses equals 7. I will now distribute combined like terms. So 3x squared plus 4x minus 2x minus 1 equals 7. Combining like terms, 3x squared plus 2x minus 1 equals 7. What kind of an equation is this? Quadratic? How do you solve quadratics? Quadratic formula would work, but something's not right. You have to set it, general form, set it to 0, which means subtract 7 from both sides. 3x squared plus 2x minus 8 equals 0. We can factor, we can complete the square, we can quadratic formula.
It's the easiest.
Factor, okay. Have I factored with y'all doing illegal math?
Yeah, like.
Okay, I'm about to do some quick illegal math in case y'all haven't seen this in a while. When factoring, the first thing you always do is determine what a times c is, right? And in this case, what would a times c be? Negative 24. So here's my illegal math. I'm going to take this 3 and multiply my constant by that 3. So I now have x squared plus 2x minus 24 equals 0. And I changed to red on purpose. Okay, so what I have done is I've taken my constant and multiplied that constant by 3. These two equations are not the same graph. These two equations do have the same solutions, though, and that's important. What I'm going to do, though, so I multiplied my constant by 3. I'm going to hold on to that 3 because I need to fix it in a little bit, which means I'm going to divide my constants by 3. Okay, I'll have to undo it. So I need two numbers that multiply together to get negative 24. So I need a product of negative 24 that combine to 2. What two numbers multiply to get negative 24, but when I combine them, I get 2.
Negative 8 and 3?
6 and 4. Oh. Negative 6 times 4. Or negative 4. Negative 6 times 6 times negative 4. Sorry.
6 and negative 4.
Yeah, that's 2.
Okay. So the two numbers I need are 6 and negative 4. 6 times negative 4 is negative 24. 6 plus negative 4 is positive 2, right? Which means my illegal equation factors into x plus 6 and x minus 4. Now, if I was to FOIL that, x times x does not give me 3x squared. So I've got a problem. Okay. So a while ago, I multiplied by 3. I multiplied my constant by 3. Now I'm going to divide my constants by 3. Yes. At this point, to reduce fractions, we're done reducing. If we have any denominators, we got to pull them to the front. So 6 over 3. Does that reduce?
Yes, it reduces.
Reduces to what?
2.
So this is going to become, I'm changing back to blue, by the way. This is now x plus 2. Does 4/3 reduce? Okay, 4/3 does not reduce, so I'm going to take that 3 and stick it in front of that x. So I get 3x minus 4. Okay, that's factored. Yes,
How come we're doing all this factoring when instead of just solving for x?
that's what I'm doing.
You can't do it with, because it's a quadratic.
It's a quadratic. I got to solve this solve for x.
Why would you choose this, doing this and not the quadratic formula?
You can do that if you wanted to. That's cool.
I didn't know if there was like.
Yeah.
a different-
From this point right here, you could have used the quadratic formula on this. I'm just taking the opportunity to show y'all a different way of factoring. So I have two possibilities, correct? So the first one, either x plus 2 equals 0 or 3x minus 4 equals 0, which means x equals -2 or x equals 4/3.
Wait, isn't that literally what we've got in every? Oh, never mind, never mind.
Okay. Now I know what x is, but I have two different values, which means I need to take both of those values. Both of these need to come over here. So I'm going to have x equals -2. And I'm going to have x equals 4/3. And I'm plugging them into this equation. So y equals 2 times -2 plus 1. 2 times -2 plus 1 is?
-3.
Y equals -3. So this solution occurs at -2, -3.
Because our y is still.
But now I need to use the other x value.
That gets you 11 thirds.
Y equals 2 times 4/3 plus 1. Y equals 8/3 plus 1. Y equals 11/3. So that solution is at 4/3, 11/3. I have a parabola with a line that goes through the parabola, touches it twice. And those are the 2 points the line touches it. Okay. Okay. So I have 3x squared plus 2x minus 8 and 2x plus 1, right? Okay. Let's go ahead and kind of change gears for just a second. I'm doing notes out of order a little bit. I'm going to solve the exact same equation by graphing. Okay, exact same equation by graphing. So here's how this looks. First of all, we have to have both equations into y equals form. Okay, the first equation, y'all are gonna have to help me. It was 3x squared
Plus 4x
plus 4x.
minus 5 equals 7.
No, that's not it.
Oh, you mean like the actual like quadratic equation?
Never mind, I'll get it myself.
Sorry.
3x squared plus 2x minus 8
Sorry.
plus 2x minus 8. Because you have to solve them both for y, correct? The other equation was like 2x plus 1. I have trust issues now. Yes. Okay. Y'all with me? Got them in?
No.
Get them in? You got it in? You do it on the calculator? You want to. You need to. Get them in. Okay, there's one right there. Okay, if I look at the graph, Does it appear that that line goes through the parabola twice?
Yes.
Guess what those are called? Intersections, which are my solutions, right? Didn't we get two solutions a while ago?
Yes.
There they are. Now, the problem with using the calculator is, well, 11 thirds and was it 11 thirds, 4 thirds? Was that the solution? Okay. That one you might recognize as a decimal. You know, if one of those solutions was like 3/7, you probably would not recognize that decimal. Anyway, this is an intersection and this is an intersection. I'm going to calculate the coordinates of those intersections. That is done using the calc button. Second, calc. I want the intersection, number 5. Now pay attention. 3 questions are going to be asked. There's only 2 equations that we put into the calculator this time. So the first 2 questions are going to be answered very simply by pressing enter. The first question is the first curve. Guys, it calls any graph a curve, even if it's a line. So the first curve was y1, correct? And you'll notice your cursor is on whatever one of the functions. I'm going to press enter. Second question is second curve. Well, it automatically gets off of one and goes to the other one. Is that my other equation? Yes. Third question is guess. Okay. The reason it wants you to guess is because there's 2 solutions up there. Here's all you have to worry about. Get close to one of them. Right now, which one am I closer to? The one on the right or the one on the left?
The one on the right.
It looks like I'm a little closer to the one on the right. So if I press enter right now, it's going to give me that one because I'm closer to it. So it doesn't matter. I can move left and right. So I'm just going to press enter and just go with the one it gives me. Okay, great. It gave me that solution. What's wrong?
It's a decimal form.
Yeah, but it should have been thirds. Should have been thirds. 3x squared plus 2x minus 8. 3x squared plus 2x minus 8 equals 0. What's wrong?
Is it because you put the y equals thing in the 0? You didn't, set it equal to-
No, that's it right there. 3x squared plus 2x minus 8. Did y'all all get the same ugly decimal that I got?
Yes.
Those aren't thirds.
Yeah. And I just plugged it in the calculator and like put in 4 thirds and 1 third. That's all. But it told us.
No, we solved it right, but something's not right. And I don't know what it is. The equation should be 3x squared plus 4x minus 7.
I think we put in 2x. Because it says 2x down there.
Well, 3x squared plus 2x minus 8.
Oh, yeah, this is the original equation, not this one. This is after we worked some stuff. Let's change that first equation to 3x squared plus 4x minus 7.
That is,
like,
I'm pretty sure that's what Heather told me.
Y'all quit joining her side or you're all gonna fail.
Happy was right.
I don't care.
Okay, so I'm gonna change this to a 4. And I'm gonna change this to a 7. I'm gonna go to my calculate the intersection.
Oh, we got the pretty number.
Okay, there they are. So this is 4 thirds and this is 11 thirds. How do I get the other one?
You just move your thingy over and then click enter.
Second calc, intersection, first curve, second curve, move it over to the left. You don't have to be on top of it. That's close enough, right? Press enter, and that solution is -2, -3.
So what is it?
Okay?
What? No, that was Hadley.
No, it was Hadley. She was right.
Don't trust Caddy. Caddy does everything backwards and upside down.
You're not going to see this one. You're going to see 9 numbers on the table. Yeah.
See, this was like
No, because we're about done with the lesson. Okay, so we got the answers right. I've shown you how to solve it by graphing. It is possible to have a solution with exactly one solution. We can have more than one solutions. We can have no solutions. We can have infinitely many if it's two lines that happen to be the same. Okay. Graphically, that's what we just did. Solve it by graphing. Look where they intersect. I'm moving on. Here are 3 examples. One solution. I have 2 lines that intersect at one point. That's one solution. 2 solutions. I have a parabola with a line going through it. No solutions. I have a parabola and a line that's above the parabola. Moving on. Graphically, I'm not going to go through the process of this. Okay. I did a graphing problem just a minute ago. So for this one, you could plug in y equals natural log of x. Then you could plug in y equals negative x plus 1, right? Calculate the intersection and you would get 1, 0. You can check them by plugging them in. Think about what would this look like if you tried to use its substitution and do it manually? Well, if y is natural log of x, I'm going to take natural log of x and plug it in for y. So I now have x plus natural log of x equals 1, and I want you to get x by itself.
Okay.
Exactly.
I'm about to do it for you.
We're not going to do it.
Wait,
And the notes are going to tell you you're not going to do it either.
I can't-
So the last example with a natural log shows the benefit of a graphical approach because that was a very simple solution to that system. However, if you try to solve x plus natural log of x equals 1, it would be difficult to solve this equation using basic algebraic techniques. We don't mess with solvers. That doesn't teach you anything. No, it doesn't teach you anything. Okay. The total cost of producing X units of a product has 2 components: initial cost and cost per unit. When enough units have been sold, the revenue equals the cost, you've reached your break-even point. So a break-even point, if you're running a company, break-even means you made no money. It also means you didn't lose any money. Okay? So the break-even point is going to be when your cost function and your revenue function intersect. If you can calculate the point where a cost function and revenue function intersect, that's going to be your break-even point. If you're running a business, you want your revenue part to be higher than your cost part, right? That's called making money. Okay. Example, and I did not erase any of this. We're just going to talk through it. A shoe company invests $300,000 in equipment to make a new line of shoes. Each pair of shoes only costs $5 to make, but they sell them for $60. How many pairs of shoes do we have to sell to break even? Okay. So the total cost of making our product is equal to the cost per item times the number of items that we make plus our setup cost. To write that into an equation, C, the total costs, is equal to 5x, $5 times the number of shoes that we make, plus 300,000 for initial cost. Are y'all good with that equation?
Yes.
Okay. What's the revenue going to be? What's the revenue equation? Revenue is going to be R. R equals what?
revenue.
Based on what they've told us. R equals what?
How much they're sold and
All I care about right now is revenue. I'm not worried about making or losing money right now. I just want to know how much money am I bringing in.
$300,000.
Huh? 60x, yes. So my revenue is 60x. My cost is 5x plus 300,000. Where's my break-even point going to be?
Wherever it intersects.
Where 60x and 5x plus 300,000 intersect. Now that's going to be way off the screen on your calculator. I'm going to go to the next portion of the slide. So my revenue is 60x. Now, at the break-even point, cost and revenue are the same. So I could actually rewrite the revenue equation as C equals 60x.
How am I gonna do that?
Well, if C equals 5x plus 300,000 and C equals 60x, can you solve this easily using algebra?
Yeah. Working on it.
Exactly. Yes. Because we're looking for the break-even point. At the break-even point, cost equals revenue.
We just write
Okay.
X equals 5x plus 300,000 over
So
60.
Allison's already told us what we write down. We write down 60x, that's our revenue, is equal to 5x plus 300,000, that's our cost.
And then we solve
That's super easy to solve, right?
Mhm.
Subtract 5x from both sides, divide both sides by 55, and we're going to have to make about 5,600 pairs of shoes. Sell about 55, 64? No, 54, 55. Once we produce and sell about 5,455 pairs of shoes, we broke even. So if I only sell 5,000 pairs of shoes, I'm losing money. If I sell 5,455 pairs of shoes, all my employees are happy, right? My equipment's paid for. The man might not have made any money, because that's where the man makes the profit, right? Correct. Another way to find this is to consider the profit function. Profit is equal to revenue minus cost. When the profit is 0, that's break even, right? So that's saying the exact same thing. And that's it.